Hello everyone, and welcome to today's session. I'm excited to have you here for ITCR 613, Mobile Systems Security. Today, we're focusing on Lecture 5, where we'll explore some suggested tools for Android penetration testing. We'll briefly go over the key tools and techniques used in this area. So, let's get started and dive into the fascinating world of Android security testing. Let's take a look at some of the key tools used in Android application penetration testing. These tools can be broadly categorized into automated and manual testing solutions. Automated tools are great for quickly scanning applications for common vulnerabilities, making them a cost-effective and fast option. However, manual testing, which combines human expertise with automated tools, can provide deeper insights into security issues. One essential tool is the Android Debug Bridge, or ADB. It's a versatile command line utility that allows you to communicate directly with a device, making it invaluable for debugging and testing. Dextojar is another useful tool. It converts files into class files, which are then zipped into a jar file. This conversion makes it easier to analyze the app's code structure. JDGUI is a graphical utility that lets you view Java source code from class files, helping you understand how an app works behind the scenes. JADX offers both command line and GUI options for generating Java source code directly from Android DEX and APK files, facilitating reverse engineering efforts. APKTOL is particularly useful for reverse engineering third-party or closed-source Android applications, allowing you to analyze their resources and manifest files. For web application testing, Burp Suite provides a comprehensive set of tools to identify and exploit vulnerabilities. Frida is a dynamic instrumentation toolkit that enables developers and security researchers to analyze running apps in real time, which is especially useful for uncovering runtime vulnerabilities. Objection builds on Frida, offering a runtime mobile exploration toolkit that helps assess app security without requiring a jailbroken device. Ghidra, developed by the NSA, is a powerful reverse engineering suite capable of analyzing complex binaries across multiple platforms. Finally, Drozer is a leading security testing framework specifically designed for Android, helping identify security weaknesses within the OS and app environment. MobSF, or Mobile Security Framework, is an all-in-one solution that automates static and dynamic analysis for Android, iOS, and Windows apps, making it a comprehensive tool for security assessments. All of these tools play a crucial role in conducting thorough security testing. Some excel at quick scanning, while others provide in-depth analysis, contributing to our overall goal of understanding and strengthening mobile app security. Let's talk about setting up the pentesting environment for Android. To perform effective assessments of Android devices and applications, we need a device to work with. This could be either a real device or an emulated one. For most initial testing, an Android Virtual Device, or AVD, is a great starting point. It's provided with Android Studio, which is the main IDE for Android development. Now, larger mobile development teams might need something more powerful, and that's where options like Genymotion and Corellium come into play. These tools offer cloud-based environments and ARM-based virtualization, which is key because ARM is the CPU architecture used in most mobile devices today. This means that with these solutions, we can spin up and customize mobile devices directly through a web browser, making our testing process more flexible. Corellium, in particular, allows us to root or jailbreak devices like Android or iPhone, which can be crucial for certain security assessments. The virtualization of ARM architecture is a significant advantage because most emulators virtualize different CPU architectures, which limits our ability to test kernel exploits effectively. Fortunately, both Corellium and Genymotion address this issue by providing ARM-based virtualization, enabling more realistic testing environments. Moving on to installing Android Studio, on Linux, it's quite straightforward. You just unzip the package and run the Studio sh script from the bin directory. For Windows and macOS, the process involves following the setup wizard, which is very similar across both platforms. This ease of setup helps us quickly establish a reliable environment for our pen testing activities. Now, on Windows, the process is quite straightforward. We start by clicking on the executable file, which is usually the setup or installer. Once we do that, a setup wizard appears, guiding us through the installation steps. It's a series of prompts where we can choose options like the installation location or additional features. After completing these steps, the main installation is done. But it's important to note that after the initial setup, there are often some components that need to be downloaded separately. So, once the setup wizard finishes, we just need to wait a little while for those remaining files to download and install in the background. This process is quite common and helps ensure that our software has all the latest updates and features. Understanding this flow is key to smoothly installing and setting up new software on Windows, which ties into the overall theme of efficient and effective system management. Once you've completed the previous steps, the next thing to do is click Finish. This finalizes your current project setup. After that, you'll want to click on New Project to start fresh on a new task or initiative. These steps are crucial because they help organize your workflow and ensure everything is saved properly before moving forward. Remember, finishing the current project correctly sets a solid foundation, and starting a new one keeps your process streamlined and efficient. So just follow these simple actions. Click Finish, then New Project, and you'll be all set to continue with your work seamlessly. All right, now let's move on to the next step. First, you want to select Empty Activity from the options available. This is important because starting with an empty activity gives us a clean slate to work with. Once you've made that selection, go ahead and click Next. In the window that appears afterward, this is where you'll confirm your choices and proceed to set up your activity. Remember, these steps are essential because they set the foundation for your project, allowing you to build your app from a solid starting point. So, be sure to select Empty Activity carefully and then click Next to move forward smoothly in the process. Finally, click Finish to complete the process. Once you've reviewed all the steps and are satisfied with everything, this is the moment to wrap it up. By clicking Finish, you're signaling that you've completed your setup or task. It's an important step because it confirms that all the information has been entered correctly and that you're ready to move on or use the system. Remember, this step ties everything together and ensures that your work is saved and finalized. So, take a moment to double-check if needed, and then go ahead and click Finish to officially conclude the process. Now that we've successfully created our new project, the next step is to wait a moment while some additional files are downloaded automatically by the IDE. This is a normal part of the setup process and ensures everything is configured correctly. Once those downloads are complete, you'll want to click on the top center of the IDE window, right here as shown in the slide. From there, select the AVD Manager, which is where we manage our virtual devices for testing. This step is crucial because it allows us to set up the environment where we can run and test our app on different device configurations. Remember, patience during this download process helps prevent errors later on. So, once you see the files finished downloading, go ahead and click on the AVD Manager to continue with the setup. This connects directly to our overall goal of preparing a reliable testing environment for our app development journey. Now, let's move on to starting the emulator. On the AVD Manager menu, you'll see the list of your configured virtual devices. To launch one, simply locate the emulator you want to test. Then, look for the green Play button next to it. Clicking this button is what actually starts the emulator. This step is crucial because it allows you to run and test your app in a controlled environment that simulates a real device. Remember, the emulator is a key tool in your development process, helping you see how your app behaves across different devices and configurations. So, clicking that green Play button is your gateway to testing and debugging your app effectively. Once the device is started, it should look like this. At this point, the initial setup is complete, and you're greeted with the main interface. This screen indicates that the device is ready for use and functioning correctly. Pay attention to the display because it shows that all systems are active and properly initialized. It's important to familiarize yourself with this view, as it's the foundation for the next steps in operating or troubleshooting the device. Remember, this is the starting point for ensuring everything runs smoothly as we move forward in our overall process. When it comes to testing Android devices for security flaws, there are several effective techniques we can use. These methods help us uncover vulnerabilities that could compromise sensitive information or alter how the app functions. For example, revering the code of an APK, which is essentially the app's package file, allows us to see how the app operates behind the scenes. Intercepting HTTP requests helps us analyze data sent between the app and servers, revealing potential data leaks. Enumerating the file structure of an installed app lets us locate sensitive files or configurations that shouldn't be accessible. All these techniques are crucial because they expose weaknesses that might otherwise be exploited. Throughout this presentation, I'll walk you through how to examine an Android device thoroughly, highlighting key strategies to identify and address security issues effectively. Now, to enumerate the file structure of an installed application, we need access to a real or emulated device. One of the most useful tools for this is the Android Debug Bridge, or ADB. It's a command line tool that allows us to communicate directly with the device. With ADB, we can install applications, debug them, and even run commands on the device through its Unix shell. Installing ADB on Linux is straightforward. You just type sudo apt install adb in the terminal. Once installed, the ADB client automatically starts an ADB server, which manages connections to all connected devices. If everything works smoothly, it detects your device automatically. But if not, we need to set up the connection manually, which we'll go over shortly. Before we can connect via ADB, we need to enable USB debugging on the device itself. To do that, we go into Settings, then About Device or About Phone, depending on the device. We scroll down to find the build number and then tap on it 7 times. When we do this, a message appears saying, "You are now a developer." This unlocks the developer options, including USB debugging. This process is crucial because it allows our device to communicate securely with ADB, enabling us to explore and analyze the application's file structure directly. Connecting via ADB, whether automatically or manually, is a key step in understanding how applications store data locally. Next, tap the back button one time and navigate to developer options. This step is crucial because it takes us deeper into the settings where we can access advanced features. By tapping back once, we're essentially stepping back from the current menu to find the developer options. Once there, you'll see a range of tools and settings designed mainly for developers, but many of these options can also help us troubleshoot or optimize our device. Remember, accessing developer options is a key part of customizing and gaining more control over your device, which ties into our overall goal of understanding how to better manage and utilize your technology. So, take your time, find the back button, and navigate to developer options carefully. All right, now let's scroll down to the debugging section. Once you're there, you want to locate the USB debugging option. It's usually listed among other debugging tools. Simply find it and enable it. This step is crucial because USB debugging allows your device to communicate directly with your computer for development purposes. Remember, enabling this option is often necessary when you're trying to troubleshoot or test your app on your device. So, take a moment to make sure it's turned on, and you'll be all set to proceed with the next steps in your setup. Now that we've successfully enabled USB debugging on our device, the next step is to install ADB on our Linux system. To do this, all we need to do is open a terminal and type in the command sudo apt install adb. This will download and install the Android Debug Bridge tools, which are essential for communicating with our device. Once ADB is installed, it's important to connect our Android device properly. So on our device, let's tap on the settings icon. Then navigate to the Wi-Fi section. From there, tap on the gear icon located at the top right corner of the screen. This will bring up the Wi-Fi details, including the IP address. Obtaining the IP address is a crucial step because it allows us to establish a network connection between our computer and the device. This setup is fundamental in the overall process of managing and debugging Android devices remotely. So, by completing these steps, we're well on our way to leveraging ADB for more advanced device management. Once we have the IP address, the next step is to connect to the device using the command adb connect 192, 168, 232, 5555. This command not only establishes the connection, but also starts an ADB server locally, which will wait for new connections. According to the official ADB documentation, port 5555 is the default port used by the ADB server for these connections. It's also interesting to note that this is the first port that the emulator will attempt to connect to in a sequence of ports, ensuring a smooth connection process. After the connection is established, we can verify the connected devices by typing ADB devices. This command lists all devices currently connected to our machine. Typically, the output will show the device either by its name and port, like emulator 5554, or by its IP address and port. In our specific case, the device appears as emulator 5554, which indicates that it's an emulator instance. Understanding this process is essential because it helps us ensure our devices are properly connected and ready for testing or development tasks, tying into the overall theme of managing and controlling multiple devices efficiently. Let's take a closer look at some of the most important directories on an Android device. Understanding these directories is crucial because they hold key data and system files that are fundamental to how the device operates. Starting with the data directory, this is where all the applications installed by the user are stored. It's essentially the home for app data. Next, the data user 0 directory contains data that only the specific app can access, which is important for app privacy and security. Moving on, the data app directory holds the APK files of the applications you've installed. These are the actual app packages. The system app directory contains pre-installed applications that come with the device, often essential system apps. The system bin directory is where you'll find binary files. These are executable files that help the system run various processes. The /data/local/tmp directory is a world-writable space, meaning any app can write to it, which can be relevant for temporary data storage or debugging. The data system directory includes system configuration files, which are vital for the device's operation and settings. Then, there's the /appensconf XML file, which contains the default access point name configurations. These are what allow the device to connect to your carrier's network. Wi-Fi configurations are stored in the /data/misc/Wi-Fi directory, holding important network settings. The /data/misc/user/0/casertsadded directory is where user-added certificates are stored, often used in secure communications. Conversely, the /etc/security/casert/directory is the system's certificate store, containing certificates managed by the system itself. And note that non-root users don't have permission to access this. Finally, the SD card directory is a symbolic link to common media folders like DCIM, downloads, music, and pictures. These are often where user media files are stored and accessed. Overall, these directories form the backbone of the device's data and system management, and understanding them helps us grasp how Android manages applications, user data, and system configurations.